So I chose to do problem 5 or project 5, and then so for letter A, the question asked if the points are spaced equally, radius of 1, what is the length of the star, which means like if I added up all the lengths of the lines together, what would that be? So, and these are all evenly spaced out points, and I am going to be using centimeters for this. So initially I would take the line of my vertical, which is, if I look, stops at 11 centimeters. So my vertical is 11 centimeters here, but that also means my horizontal straight is also 11 centimeters because if they're equally spaced out, then my lines should be the same length as each other. So that would mean this line is 11 centimeters, this line is 11 centimeters, and then these two lines are 11 centimeters. And then I take the length of my diagonal centimeters, which comes out to be about 10.3-ish centimeters. I'm going to round that up to 10.5 centimeters. So my diagonals are 10.5, and it's the same thing as the vertical, that my diagonals should be the same length. If I measure this one just to be safe, it does come out to be at 10.5, 10.3 centimeters area. So if I just add that up, if I multiply 11 by 4, I get 44. And then if I multiply 10.5 by 4, I will get 10.5 times 4 equals 42. So then I will get 42. So then I add those up, and that equals 86 is my total length of a star with equal points set to each other. So the next problem or letter will be letter B. So letter B, I'm going to draw my circle here. Like this, so my equal circle. Letter B is easy. If the spaces if the points do not need to be spaced equally around the circle, what is the longest that star can be? So that's kind of saying in what way can my star be longer this way? So like vertical wise or horizontal wise, what is the longest my star can go this way? And then that basically means if I took my 2 points from here and I just smush those together, what would I get? So I'd basically get a straight line down this way because my 2 points come together, and then I would get another straight line this way. So I have my 2 straight lines right there, but I will still have my diagonals. So I'll put my diagonals at each endpoint here, and then I'll put my other diagonal right here, and then I get my last 2 going this way. So I get it here, and then I get another one right here. So essentially what I have is I just have a little square that's tilted, but that is also what my star could be at its longest point. So then if I take the measurements here, this comes out to be 11.5 centimeters. So my length, or my vertical and my horizontal straight lines, will be 11.5 centimeters, 11.5, 11.5. And then I take the length of my diagonal, which comes out to be 8 centimeters. So I get 8 centimeters here, and then 8 centimeters here, and then vice versa for my other 2 diagonal lines. So then I just add those lengths together. 11.5 plus 11.5 equals 23. So that's 23 for my vertical and horizontal. And I got 8 and 8 for my diagonals for 2 ways, and then another 8 and 8, so that's 8 times 4, which equals 32. So my total length for the longest star I can have equals 55. And then for question C is what is my length? What can my length be if my shortest star? And if you actually do it, the shortest star is just my square turned the other way. So instead of my lines here coming in this way, my lines will actually come out that way, which means my diagonals are actually going to come in this way. So my diagonals actually turn into my new horizontal lines and vertical lines, and I'll just get the exact same square, which means I'm going to get the exact same numbers. So if the longest star is 55, then my shortest star will also be 55 in terms of length, just because of how the numbers still balance, and I get the exact same square. My square is just tilted 45-degree angles. So longest equals 55, shortest will also equal 55. So I've moved on to part D, which is put points in Excel and then graph the curve that I get. So for my point, you can see that on the left I have my length of the star, which is all the lines, the length of all the lines added together, and then I have the space of points. And so for space of points, I started off at 0, because if you see here, my points are actually have no spaces in between, and the length of my star was actually 55. So then after that, I moved on to a smaller space points, bigger than 0 but smaller, which is actually 2.5, and the length of it is 84. Then I go to my balanced, or my evenly spaced star, and that is 4 centimeters of space in between each point, and for that I get 86. And the 86 for the balance is actually the peak of what I get, because then when I move on to 5, it actually drops, and then I go to 7, I go to 6, and then it drops, and then I go to 8, and then it actually goes back to drops. And 8 is actually my other one where my points have the length of the farthest it can be spread out, which is 8 centimeters. So that 8 centimeters equals 55. So then for my graph, you can actually see that the graph is a parabola, which makes sense because you start at 1 point, or you start at 0 points, and that is the length of your thing. But as you keep going up, you get to the certain peak, which was my 4 centimeters. But then once you keep getting bigger, the curve actually starts going back to what you originally had. So a parabola does make sense in this scenario.